Hi guys, welcome to the lesson of partial differential equations, and today we will take one more problem on quasi-linear first order partial differential equations. So in the previous class we solved the problem, and now we'll take one more problem and then we will move on to the next topic. So it's ut plus u times ux equals x, and the initial value is given that u of x comma 0 equals 1. Okay, so we can see that this problem is quasi-linear because of this term here. And if you remember that the general form is x comma y comma u times ux plus f2 x comma y comma u times u y or ut equals f3 of x comma y comma u. So this is the general form or standard form of quasi-linear partial differential equations of first order. Now to construct the Lagrange form, we can write this as dt over 1, that is the coefficient of ut is 1, equals dx over u, that is equals to du over x. Now this is the Lagrange form for this problem, and we can see that we have some pair from here. We can see here and here. These make the separable equations. So we can write dx over u is equals to du over x. We can separate the variables, so it's x dx equals u du, and on integrating this function, we get x squared over 2 plus c1 equals u squared over 2. Or we can write c1 equals to u squared over 2 minus x squared over 2. So this is one of the function. And now for the second one, what we can do here is we can, if we subtract these or we add these in this manner, that du plus dx over u plus x equals dt, then we are also going to get a curve from here, because we know that if these three ratios are equal, then the sum of the ratios in this manner, the numerators and denominators, is also equals to the ratio. So now we can write du plus dx over u plus x equals dt. Therefore, we can write d of u plus x over u plus x equals dt, and we can simply integrate these curves. So here we will get this is du plus x and this is u plus x. So simply we can write ln u plus x, because the derivative of the denominator is in the numerator, and then here we have t plus ln c2, or we can write minus ln c2 for our ease, because we will move it to the left side. So it will be ln u plus x plus ln c2 equals t, and this gives that t equals u plus x times c2. All right, so again, not just like this. This is ln, and this is Now we are going to take on the exponential to get rid of this ln, so we will get u plus x times c2 is equals to e to the power t, and then on some more algebraic manipulation, we can get that u plus x times e to the power negative t equals, then we move this c2 over the another side, so it is 1 over c2, and we can write it as a, this thing as a because this is a constant, so we can write a equals u plus x times e to the power negative t. So this is the second curve. So one curve we already have, that is u squared minus x squared equals c1, and from here one thing we can also do is that we can write only u squared minus x squared equals c, right? Because this 2 is just the LCM, and it will multiply on the left side with c1, and it makes a constant, so we can call it 2c as c, so 2c1 as c. So we have two curves now, that is x squared u squared, in fact, minus x squared equals c, and a equals to u plus x to the power times e to the power negative t. So we have two curves, and we can write here that instead of this a, we can write that okay, so for c also we can write that u squared minus x squared equals to function of a. Instead of c, we can write in the similar fashion that we did in the previous lessons for linear partial differential equations. And this will be function of u plus x times e to the power negative t. And we have the initial conditions to solve this problem. So the initial condition in this case is given as u of x comma 0 equals 1. So we can just plug 1 instead of u minus x in place of x, and this will be f of u plus x, which means 1 plus x to the power times e to the power 0 as t is 0. So f of 1 plus x is equals to 1 minus x squared. So this we have f of 1 plus x as 1 minus x squared. So we have f of 1 plus x equals 1 minus x squared. So we can write that f of x will be simply equals to 1 minus x minus 1 squared. So how I did that, because we have 1 plus x here, if I assume that x equals x minus 1 instead of x 1 plus x, I am taking x minus 1, that 1 will cancel with this one, then I have to put here also x minus 1 squared. So this will be 1 minus x squared plus 2x minus 1, and then we will get this will be equals to x times 2 minus x. So f of x is equals to x times 2 minus x. Therefore, this function here, f of u plus x into e power minus t, that is f of u plus x times e to the power negative t. We just need to plug this thing in every x. So it will be u plus x times e to the power negative t times 2 minus u plus x e to the power negative t, and this will be u plus x 2 times u plus x e to the power negative t minus u plus x squared e to the power negative 2t. So this function u plus x e to the power negative t is equals to this thing. Then we can just put this thing here in this equation. That is, let's say it's equation number 1. So it will be u squared minus x squared, u squared minus x squared is equals to this whole thing. So we have u squared equals 2 plus 2 times, sorry, u plus x into e to the power negative t minus u plus x whole squared e to the power negative 2t. And if we want to simplify this one, we can simplify it by some algebraic manipulation. So we can write this as u plus x times u plus y. Sorry, u minus x. That will be equals to u plus x common from both sides, from both components, and 2 e to the power negative t minus e to the power negative 2t. Then this will cancel out and we will left with u minus x equals 2 e to the power negative t minus e to the power negative 2t. And furthermore, if we want to simplify this function, then okay, one thing I missed here, that u plus x is still here because it was u plus x squared here. So u plus x is still here. So it's with e to the power negative 2t. So u plus x is still here. Okay. Now what we can do is we can write u minus x equals 2 e to the power negative t minus u times e to the power negative 2t minus x e to the power negative 2t. And this component here we can move to the left side with the u. So u common, 1 plus e to the power negative 2t, and move this x to the right side. So it will be plus x times 1 minus e to the power negative 2t. So this is now u equals 2 e to the power negative t divided by 1 plus e to the power negative 2t plus x times 1 minus e to the power negative 2t times, divided by 1 plus e to the power negative 2t. And by this, we get the answer u in terms of x and t. So in this manner, we can do this problem, and if you simplify it more, the final result you can get is x times tangent hyperbolic t plus sec hyperbolic t. That I will leave it to you to simplify to this form. So I hope you will understand this lesson, and that's all for the time being. We will come up with next video lecture, next topic. Thanks for watching the lesson.